video, we're going to talk about trigonometry. Now, the first thing you need to know under trigonometry is the Pythagorean theorem. And what does the Pythagorean theorem state? Now, let us say we have a right angle triangle. I just hope my diagram is perfect. So this is the right angle, and let us say this is the angle A, and let's say this is the angle B. Let's say this is the angle C. Now, this angle actually has a side that faces it. That is going to be the side. The side CB is the angle that faces the side A. So we could call that as a small a. And the side that faces the angle C, that will be called as a small c. And the side that faces the angle B, that will be called as a small b or lowercase b. Now the Pythagorean theorem states that you're actually going to have the square root of the hypotenuse be equal to the square root of the adjacent added to the square of the opposite side. And that is actually with respect to an angle under consideration. So let us take this. This is the adjacent, and we also need to have the opposite. And this is basically what it's going to be. So let us say that we have this as the angle. This is the angle theta. Now, if we picked out this angle, this side actually lies adjacent to this angle. So with respect to the angle theta, this is going to be the adjacent. Now, the longest side of a Pythagorean triangle, that is a right angle triangle. That is actually the hypotenuse. So in this case, C, the side C, is the hypotenuse. Now, this is the side that faces the angle theta. That side is going to be called as the opposite. So if we actually wanted to use this formula to find out what is going to be the third side or the hypotenuse, we know that the hypotenuse in this case with respect to this angle, that is actually the C. So I'm going to write that as a C squared. And this is going to be equal to the adjacent squared, which we know now is going to be A squared. That is because this angle, this is the side that lies beside it. So that is going to be an A squared. So you're going to add that to the opposite squared, which is actually B squared. So that is going to be B squared. Now this formula, we're actually going to use it frequently. So you just need to bear these at the back. It's going to be very useful. Now let us take some examples. So let us say that you have a right angle triangle in this form. And this side is a 4. And let us say this side, you got a 6. Let's say this is A, this is B, and this is a C. What is going to be the side AB? If you are asked to find the side AB, how are you going to solve it? Now, as far as we have this representation, that is this symbol represented here, that means this stuff is actually a right angle triangle. Now, in order to solve it, we need to use the Pythagorean theorem. So we know that from the Pythagorean theorem, you must have the hypotenuse squared be equal to the adjacent squared plus the opposite squared. Now this stuff, which is the hypotenuse, we need to work it with respect to an angle. Now you could well do it for this angle. Let's say this is theta, and let's say this is the angle alpha. Now you just need to know that whichever angle we consider between this and this would actually give us the same answer. So you may not really need to specify which angle you're actually dealing with, except we actually have some other stuff to work. There is something else called as the SOHCAHTOA. This stuff actually helps us to find out the relationship between the opposite and the hypotenuse, the adjacent and the hypotenuse, as well as the opposite and the adjacent. We're going to use some trigonometric ratios to find out. So we're just going to go gradually. Later on, we're going to come into that. Now, you got hypotenuse squared. You need to know that the hypotenuse is the longest side. And that is actually the AB, which you see there. So that is going to be an AB, and this will be squared. And on this other side, we have the adjacent, which is actually the side of your choice. Now another person may choose 6 as the adjacent. Now if you chose a 6 as the adjacent, what that means is you actually picked out this angle as the angle under consideration. If you picked out this angle, then you're going to have that this side will be the opposite side to this angle alpha. And this side 6 or 6 units will be the side that is adjacent to the angle alpha. If you picked out the theta, you're going to have that this side 4 is actually the side beside the angle of theta, and this will be the opposite. But that is actually going to be the same thing, so we really don't need to get worried about that. Now this side could be called as adjacent, and that is CB. I'm going to call that as a CB, and that will be squared. And on the other side we have an AC squared. So this is going to be AC squared. Now we need to find what AB is. That is this side. So I'm just going to write that as an X. We need to find what X is. Now we know that CB, that is 4 units. So I'm just going to write that there. So that will be 4 squared. And on the other side we have a 6. That is going to be 6 squared. If you took a 4 squared, that should give you a 16. And 6 squared is going to give you a 36. So we need to combine these. Now if you have a 16 plus a 36, what is that going to give? Basically that should give you a 52. So what we got is AB squared is equal to 52. So in order to get the AB, we need to take the square root of the other side. Basically we need to take the square root of both sides. So I think I need to rewrite these up here. Now if I take the square root of both sides, this is going to cancel this. So this will be cancelled by the 2 there. That will leave us with an AB, which is what you see here. And this side we need to find the square root of 5, well, that is 52 rather. Now it happens to be that there is no whole root for 52. So basically that is just where we're going to stop. So this is basically how to find it. This is how to use the Pythagorean theorem. Hopefully you understand the point right now. Now we're going to try out the second stuff that you need to know under trig, which is actually the relationship between the sides of a right angle triangle. Now you need to know that you could form right angle triangles from a square. You could form it from a square. That is, if I took a diagonal that bisects the angle 90 degrees, I'm going to have a new form, something like this. I can also do it with a rectangle. So to redraw this, something like this, and you're going to have this. You could well create a right angle triangle with this. You could also use an isosceles triangle. That is a triangle that has 2 angles equal. So this is going to be equal, while this is actually different. Now what that means is this side, this is the side X, will be equal to this other side. Now this side may be different, but these sides are always equal. So I'm going to write something like this on that. So this is an isosceles triangle, and you could also have the equilateral triangle like this. In this case, you actually have all the sides equal. So this is going to be equal to all of this. That means the angles are always going to be equal, and that would always be 60 degrees. So for an equilateral triangle, there is always going to be 60 degrees as the angle for each of the angles within an equilateral triangle. Now there is also another triangle which is called as a scalene triangle, something like this. For this angle, you actually have no side equal to any other side. So if we said this is an A, this is a B, and this is a C, you would actually find that this is actually a Y. And on the other side, you're going to have this as a X. And let's say this is actually a Z. That is basically how this stuff works. All these triangles are actually going to be needful as we study trigonometry. Now let us move on to these relationships, which I actually spoke about. Now the mnemonic for it is actually this. you have SOHCAHTOA. Now this stuff stands for sine, which is actually opposite divided by hypotenuse. This stuff stands for CA. That stands for the cosine, which is equal to adjacent divided by hypotenuse. You also got this other one. This actually stands for tangent. So let us take it out. Now I think I'm gonna use this. So let us say that we got this as theta, and let's say this is actually the alpha. Let's say we got A here, this is a B, let's say this is a C. So this is going to be a small c or lowercase c. This is a lowercase a, and this is going to be lowercase b. Now, if you got a sine theta, this is what you're going to have. We know that sine has opposite and the hypotenuse attached to them or to it. That means you're going to have a opposite divided by hypotenuse. Now, what is the opposite with respect to the angle theta? This is actually a b. That is the side that is opposite to the angle theta. So obviously that should be a b. Now, what is the side of the hypotenuse? That is a c. So we need to write that as a c. So what you're trying to say is that sine theta with respect to this angle is actually equal to b divided by c. How about sine alpha? How is it going to look? We know this should be also opposite divided by the hypotenuse. Now, in this case, the opposite with respect to this would actually be different. The opposite to this angle, that is going to be an A. So we should have an A, and that will be divided by a C. So you can see that these two stuff, they're not actually equal to each other. So sine alpha is actually going to be different from sine theta. You just need to bear that at the back. So I'm just going to wipe these out for now. Next up, we're going to deal with cosine theta. Now that is actually supposed to be adjacent divided by the hypotenuse. This is going to give you A, which is actually that stuff, and that will be divided by hypotenuse, which is a C. So this is what you get. Now notice that this is actually the same thing with the sine alpha, which we tried to find just previously. So we're going to come to talk about this later on, but just hold this at the back that this stuff, they actually work. That means cosine theta and sine alpha would actually be the relationship which you would need to combine complementary angles. Those are angles that add up to give 90 degrees. Now let us go on to tan theta. So if you had tan theta, that should be opposite divided by adjacent. Now what is the opposite? With respect to theta, the opposite should be a b, and the adjacent obviously is going to be an a. So this is basically how to work it. Now I just need to show you something more. You could have the reciprocal form of the sine theta. The reciprocal form of sine theta, that will be written as a cosecant theta. So I'm just going to write it as a cosecant theta or it's cosec theta. Now if you have that, just as the word implies, you just need to reciprocate the stuff which you have there. First, you're going to have it as hypotenuse divided by opposite. So that would give you a C divided by a B. If you wanted to find the reciprocal of a cosine theta, that is actually called as a secant theta. Now for the secant theta, if you wanted to find out, obviously that should be a hypotenuse divided by the adjacent. And so in that case, we're going to have a C divided by an A. And the next one is tan theta. If you got tan theta, that should give you cotangent. That is actually the reciprocal of a tangent. So that is a cotangent. It's shortly written as a cot. So we're going to have a cot theta. I'll write it better. And so you should have an A divided by B. For the formula, you just need to reciprocate all these stuff to get the reciprocal form of the trigonometric ratios. So hopefully you get the point by now. SOHCAHTOA is very useful if you have right-angled triangles. If you are able to use a right-angled triangle or you actually have an equilateral triangle or an isosceles triangle, you could use this formula to find out what is the side or the angle in question. So let us take a brief example under this. Now let us say that you have something like this, and let's say this is a 30-degree. This is 90, and we have this as the A, and this is the B. This is a C, and let us say that we have this side to be 4 units, and let's say this is the side X, and this side, let us say this is the side Y. Now you could be asked to find out what is the side Y as well as X. Now, if we are actually able to find out what Y is, we could use that to find out, well, this is an X, right? So if we are able to find out what X is, we can find out what Y is in essence, because we could use the Pythagorean theorem and get to that point. So this is what we're going to do. We know that from SOHCAHTOA, we have the relationship between this side and this side working for us. That will be sine 30, because in this case, we have a 30 as the angle present within that position. So this is going to be sine 30 degrees, and that will be opposite divided by the hypotenuse. Now the opposite side to the angle 30, that is an x. So you're going to have an x there, and then you have hypotenuse. Well, unfortunately, we could not really find out. This is actually x divided by y. So in this case, we're just going to put it in perspective. We would come back to it later on. So let us go on to cosine. Or I might just well use tangent. So tan 30 is actually what I'm going to use. So tan 30, that is actually opposite divided by the adjacent. Now I know that the opposite is the x, and the adjacent is a 4. Now what is tan 30? What are you going to get? Tan 30 is root 3 divided by 3. We're actually going to come to that point where we derive all these values. So this is going to be equal to x divided by 4. I think I'm just going to take these out for now. Now we could cross multiply from this place, and so we should have a 4 multiplied by root 3, which should give us a 4 root 3. And on these other side, we're going to have a 3x. Now next up, we need to find what x is. So that is going to be divided by 3 in it. So this is going to cancel. That would leave us with a 4. Well, need to rewrite that. A 4 root 3 divided by 3. This is what you're going to have. This is the answer for x. Now, if we have this answer, we could actually use it to find out what y is. If you don't want to use it that way, you could use any other form. Now, let us say we know this side is actually 60 degrees. Now, why is that? Why is this side a 60 degree? We have that to be because this is a 90 degree and this is a 30. And if you added a 90 to a 30, that should give you 120. Now we need to have 180 degrees within every triangle. So you just need to take 120 degrees away from 180. That is going to give you a 60 degree. So that will be the angle left in this position. Now you could use this to find out what y is from this point. So this is what I'm going to do. From here, I know that 4 units is the unit for this side that faces the angle 60 degree. Now I also know that y is actually the hypotenuse with respect to 60. So I could well use sine. That will be sine 60 degree. That is opposite divided by hypotenuse. Now the opposite obviously is a 4. And the hypotenuse is a y. So here now we got sine 60 degree. Sine 60 degree, that is root 3 divided by 2. This is going to be equal to 4 divided by a y. Now I just need to place this stuff in perspective because we're going to use it later on. So I'm just going to leave this part. Now we need to cross multiply from this equation. So that will give us a y root 3, and this will be equal to 4 multiplied by 2. And this should give us an 8. And so we're going to have a y root 3 is equal to an 8. Now we need to find a y. So in order to find that, we need to divide through by root 3. So y will be equal to 8 divided by root 3. Now you could well rationalize this expression by multiplying it by a 1. Now 1 will be the same thing as root 3 divided by 3. So this is going to be y, and that will be 8 divided by root 3, and that will be multiplied by root 3 divided by root 3. Now we have 8 multiplied by root 3. That would give us 8 root 3. And this is divided by root 3 multiplied by root 3. Basically, the answer is always going to be 3. If you have root a multiplied by root a, the answer is going to be an 8. You just need to pick out one of the terms within the square roots. That will be the answer. So this is actually the answer for y. And so basically that is how to work it. Hopefully you understand the point. If you do not, feel free to rewind the video and go through it all over again. Now we are going to talk about reciprocals of the trigonometric ratios. The three basic trigonometric ratios which we have are actually the sine theta. Well, I should actually call it the sine of any angle. In this case, I'm actually just going to take the sine as the sine of theta. Or I should just use it as a normal sine. So I'm just going to leave it as a sine here. Now, the next one is a cosine. And the last one is a tangent. Now, all these trigonometric ratios, they actually have their reciprocals. So let us say that the angle under consideration is theta. If I had an angle and I wanted to find out what will be sine theta of it, so let's say this is theta, and I could find the sine theta of that angle. Now this is just an arbitrary form of a derivation, so we do not really need to label this triangle. You just need to know that we could find sine theta. We could also find cosine theta. That will be written as cos theta. Now tangent theta, that is written as tan theta. Now this stuff, they have their reciprocal forms. The reciprocal form of sine theta is actually 1 divided by cosine theta. Whoa, what a mistake on my part. There should be a sine theta. Now this stuff is also called as a cosecant theta. Now what you need to know is that this could also be written as this. You could write this as a sine theta or raised to the power of a -1. Now, before we go on, you could have another trigonometric representation in this form, sine to the -1 of theta. This is not the same thing as this other stuff. If you have this, these two, they're actually completely different. This means the sine inverse of the angle theta, while this stands for the reciprocal of sine theta. So this stands for the inverse form of the angle theta, while this stands for the inverse form of the whole sine theta. So in one way, I could well call this as the inverse. And this is going to be called as the reciprocal. So you just need to hold that at the back. Bear in mind, this is not the same thing as this. So I'm going to take these out. Now coming to the sine, we have that the inverse, well, this is not going to be the inverse. This will be the reciprocal of a cosine theta. That will be written as 1 divided by cos theta. and that is going to be equal to secant theta or sec theta. This is cosecant theta. This is sec theta, which also stands for secant theta. And the last one we got is 1 divided by tan theta. And that is actually equal to cotangent theta, which is always written as a cot theta. So you just need to hold these at the back, because later on we're actually going to use them to work some derivations as well as calculations. Now next up, we're going to deal with complementary angles. So what are complementary angles? And how can you use them if you have a right angle triangle? Now let us make a representation for a right angle triangle in this way. So this is the right angle, and let us say this is a theta. I'm going to call these as an alpha. So this is angle A, this is going to be the angle B, and I'm going to label this as the angle C. Now let us say this is an A. Whoa, that is a mistake. There should be a C. This is the A and this is the B. Now first off, we know that if you have alpha plus theta plus a 90 degree, which is actually the representation for that form there, that is going to be equal to 180 degrees. This is because the sum of the angles within every triangle is always going to be 180 degrees. Now if I took this to the other side, I'm going to have alpha plus a theta that will be equal to 180 minus a 90. This stuff should give me a 90, so I'm going to have alpha plus theta is equal to a 90 degree. Now this is exactly what we're trying to say. You have that alpha plus theta gives you a 90 degree. This is what we call complementary angles. They are complementary because they add up to give a 90 degree. So those are complementary angles. Now this is what you need to know. I could express alpha in terms of theta. How am I going to do that? I just need to take out theta from this side and take it to the other side. So that will be 90 degrees minus the theta. Now in the same vein, I could have it as a 90 degree minus alpha. All these are actually going to work. And these will be actually so needful that we're going to use them to find out how complementary angles work when we come to work some stuff. So in this case, you can say that alpha, which is here, this could be written in terms of the alpha. So instead of writing the theta, which is there, we could write 90 minus an alpha for this angle. And that is actually pretty reasonable in it, because we have this as a 90, and we know that this stuff, they must add up to give a 90. Because if you have a 90 degree added to another 90 degree, that should give you 180. So that is basically the form. Now in that case, we're going to say that if you took out this away from the 90, that should give you the remaining part of that 90, which is the alpha. And if you took alpha away from 90, that will leave you with stuff which is on this other side. So theta is the same thing as 90 minus alpha, and alpha could also be written in terms of a theta. So that will be a 90 minus a theta. Now let us try to work some stuff. I think I'm gonna take these out and place it in red. Just need to hold these at the back. Now let us try to work something. If I took the sine of a theta, we know that should be opposite divided by hypotenuse. This is a sine theta, and the opposite side to it is actually the b. So I'm going to write that as a b. The hypotenuse is a c, so that is going to be a c. Now you already know, if I wanted to find out the reciprocal form of the sine theta, that should be c divided by b. That will be called as a cosecant theta. Now what if I wanted to find out what will be the cosine of this angle? Now that is going to be cosine of alpha. Bear in mind, this is different from the theta, so that is actually represented as an alpha. Now we already said from this expression that alpha is equal to 90 minus theta. So I could also write this as a cos 90 minus a, well, that should be minus a theta. So this is the same thing as a this. Now you can see from here that we have expressed cosine theta in terms, well, I've actually expressed cosine in terms of theta. So I could use this to find the relationship between itself and this stuff. So let us find out what that's going to be. So that is cos 90 minus the theta in it. Now we know that this stuff, there is a little bit of a relationship. We're going to find that in a little while. We know this is the same thing as cos alpha, right? So I'm just going to write it over here. This is cos alpha. Now we know that cos should be equal to adjacent divided by hypotenuse. Now this is the angle alpha. What is the side that is beside it? That is actually a b. So I should write a b here, and that will be divided by this side of hypotenuse, which is actually c. So that is divided by c. Now notice that these two stuff, they're actually equal to each other. Sine theta is equal to cosine alpha, which is equal to b divided by c. Now another way to write cosine alpha is actually cosine 90 minus theta. So from this place, we can find that cosine 90 minus alpha, well, minus theta rather, is equal to b divided by c. So we are creating a proof here that if you have sine theta, that will be equal to cosine 90 minus the theta. And this is actually a brilliant law or a rule for the complementary angles. Now, in the same vein, you're going to have that work for sine alpha and cosine 90 minus alpha. So let us say that you have a sine alpha in question now. Now this is alpha, and the opposite to this the angle, that is actually a. And so you got the a there. That will be divided by the hypotenuse, which is a c. So this should be a divided by c. Now as usual, you know that alpha is equal to 90 minus a theta. So I'm going to work cos theta. Now theta is equal to 90 minus the alpha. So this is going to be cos 90 minus the alpha. So let us just find cos theta directly. Now as you well know, this is actually adjacent divided by the hypotenuse. Now the adjacent to the angle theta, that is the side which is beside the angle theta, that is an a. And then the hypotenuse, that is a c. Notice these two, they are equal once again. So in this case, we're going to say that sine alpha is equal to cosine theta. But the best way to make it more linear or homogeneous is actually try to work or make this theta in terms of the alpha. Now we know that theta is the same thing as 90 minus alpha. Well, so I need to take this back. So we have found here that sine alpha, which was equal to a divided by c, is the same thing as cosine 90 minus alpha. And that is what you're going to have. And so this would actually be the new form. You're going to have this stuff. And this too, they're actually the expressions for complementary angles. Now you need to know that you could express this in terms of cosine also. So I'm just going to show you that briefly now. Now if you do not really want to write it in terms of sine, you could write it in terms of cosine. And if you worked it, that would give you the same thing as what you have here. So you could also have a cos alpha that will be equal to sine 90 minus the alpha. You could also have a cos theta that will be equal to a sine 90 minus a theta. So all these are actually possible. You just need to bear it at the back.